Okay, so today we're going to go over basic integration. That's going to include common integration techniques and formulas. Okay, I forgot to add the dx, which you must add at the end of every integration setup. Essentially, it's just stating that you're integrating with respect to x, or whatever variable you're integrating with respect to. So if we were integrating with respect to d theta, if we're integrating with respect to theta, you must add d theta at the end of every integration setup. Sorry, I was talking about d theta and I ended up writing that. But since these are all integrated with respect to x, we're going to put d of x. I should also address the plus c that you see at the end of most equations that I forgot to add here. C is a variable that represents a constant. The reason we have that is because we'll think of integration as the opposite of differentiation. When you're deriving a constant, it is equal to 0. And so when you're integrating any function, that constant that you originally start off with is lost. Because if we were to integrate, let's say, x squared plus 2, we would end up with 2x. But if we were to integrate 2x, we would end up with x squared. And so there's clearly a constant missing, and that's why we add plus c. If you are integrating with parameters, you do not need this. But since we are integrating without parameters, you need to add plus c, and it just represents any variable. Now this formula over here, 1 over x, is a bit difficult to understand. It doesn't really make sense. But you just have to remember this. I'm sure there's some sort of proof, but I don't know it right now. So you're just going to have to remember that when integrating 1 over x, it's equal to natural log x plus c. Let's look down here at e to the power of x. As you know, if you were to derive e to the power of x, you would end up with e to the power of x. And so when integrating e to the power of x, you also end up with e to the power of x, except you have to add the constant c. Over here, we can see that the integral of cosine of x is equal to sine of x plus c. The reason behind this being the derivative of sine of x is equal to cosine of x. Now the integral of sine of x is equal to negative cosine of x. And this is because if you were to differentiate cosine of x, you would end up with negative sine of x. And so to integrate sine of x, you would end up with negative cosine of x. If you were to integrate negative sine of x, you would end up with cosine of x. Okay, so this is example problem 1. We're trying to integrate 1 over x squared. And you may think at first that this could be natural log x plus c. But I specified earlier that the derivative of natural log x is 1 over x. So it can't be natural log x because it is raised to a power that isn't 1. So let's make this easier on ourselves, and let's equate this to x to the power of negative 2. Now we can obviously use the first formula that we went over earlier. And so the formula is 1 over n plus 1, x to the power of n plus 1. Now n in this case is negative 2. And so 1 over negative 2 plus 1, that is negative 1, times x to the power of negative 2 plus 1, which is negative 1. And so this whole thing is equal to negative 1 over x plus c. All right, so this is example problem 2. Let's make this easier on ourselves. Let's factor out the 2 because 2 is just a constant and you can always do that. You can always factor them out when integrating. So this is now equal to 2 times the integral of 1 over x. Hopefully you can remember that 1 over x, the integral of 1 over x, is simply equal to natural log x. So we end up with 2 times natural log x plus c.